said, this is my background. I'll let you read that if you want to, but Tuba did cover it. Just a really warm welcome to you all. I personally go to some of these online talks, and they're a bit strange because I can't see and hear you. Hopefully you can see and hear me clearly. But I would really like to personally say welcome. I really enjoyed being in Pakistan and speaking to lots of teachers when I visited, and it seems lovely to be able to present in this way, but I would very much like to be there in person. Okay, so that's me. The books, the Oxford Primary Science books that I've been working on, as you know, there's been lots and lots of changes, and the new final kind of single national curriculum is very prescriptive. It's very clear and tight, and so we've made the books, fully revised them in order to align with the SNC, and in there is an emphasis, rightly so, on scientific literacy, for students to be able to use scientific language and to understand scientific ideas and approaches. There's also, of course, the idea of wonder and curiosity, which we need to facilitate in our students in order for them to be able to think scientifically. So I'm going to talk a little bit about that in these and give you some ideas about doing that. And obviously we need to, especially in the primary sector, make science seem something everyday, something that we all use, because we do, but those links aren't necessarily clear. And if we want to be thinking about STEM careers and promoting STEM careers from a young age, then we need to build this awareness of science as part of everyday life. So the curriculum emphasises that, but also these books do too. And then, facing us all are major environmental issues, something I'm very passionate about, and something that is really relevant around the world. So I have incorporated both into the books, as according to the SNC, the environmental issues, but I'll also be trying to touch on those today as well. Okay, so we've got to make science inquiry-based. We've got to be able to foster this wonder and curiosity. And I'm just going to tell you a little bit more about the books so that you can know that they've got all of these things that you need in them. One main thing, though, is that I can't stress enough, and I know my father, Nicholas Salisbury, he would also stress very strongly, is that the textbook is a useful resource. It's a resource for you, primarily as the teacher. It gives you a structure, it gives you the content, it gives you reassurance. In some cases, if you're new to teaching, it may be your first port of call for your own personal knowledge bank. It's a source of ideas because you're teaching a wide range of children, a wide range of subjects, and it's hard when we're teaching to keep coming up with fresh new ideas. So the textbook gives you that, and all the examples that I use today will be are in the textbook. So you should. Obviously I've picked from different years, but they were all there. So use it, read it. If you're teaching, this is a copy of the book for grade 4, but if you're teaching them, for example, read it in advance, get used to it, and get familiar with the style. So I'll talk a little bit more about what we have in the books now. So the SLOs are really clearly displayed at the start of each unit, and they make it very clear for you to be able to see what's being covered and for you to be able to use them for your planning. Now, they are the learning objectives from the national curriculum. So for students, they won't necessarily feel familiar at the start of a unit. But the textbook for the students is something for them to go to once they've done some active learning. It's for them to use as a revision resource. It's for them to dip into, to recover things again, or to revise. And so when they are familiar with that, they will be able to look back and look at these "you will learn to" and see that they have learnt those things. So they operate both as a tool for you and as a tool for the students. Within the textbooks themselves, we've also got headings, subheadings, we've got the glossary, we've got concept checks, we've got discussion exercises, loads of illustrations and diagrams that can be used, and I'll talk a bit more about that in a bit, and lots of additional eye-catching info boxes. So they're a really bright, vibrant tool for the students and for yourself, and obviously they're full of activities and also end-of-unit exercises. And you will be able to have opportunities if you prepare in the way that I suggested, which is to read through the part that you're going to be covering. You will be able to have lots of opportunities throughout your teaching, from the get-go of a lesson or a series of lessons right the way through to the end, of different types of assessment opportunities, where you can look at their prior learning, their ongoing learning, formative and also summative. But don't get stuck with that. Don't get stuck with the idea of opening page 1 and starting there and working through. The textbooks have, for year 4 and year 5, there's 10 units, and the final unit is all about technology. So it's a really good unit to dip into when you feel that you have you need to recap that key aspect. Okay, so the symbol that you can see at the bottom middle of this slide highlights certain activities and certain tasks that are really key for technology in everyday life, which is a kind of main angle for my talk as well today. Okay. So what I would like to do next is just to give you a little heads up that there are going to be quite a few ideas. In books 4 and 5, there are 3 units allocated to living things, the life sciences. And so in your planning, get these concepts made real through experience, so that there's understanding. So now I'm going to suggest lots of ideas, and as I said, they're all from the books. So in books 4 and 5, there are 3 units allocated to living things, the life sciences. And so in your planning, those 3 units need to be allocated a lot more time than for other units which feature other parts which feature 1 or 2 units. So part of your planning for the year is that you need to allocate a significant proportion of time to each of the sections of the book, remembering that Unit 10 is something that you can dip into. So start by getting familiar with the books, especially if you've been using the New Oxford Modern English prior to this, because the changes have happened, and the changes are there because they reflect how the students will be assessed and what the SNC demands. So here's the first idea. What I would do if I was beginning this is I would try to tap into the students' prior knowledge. So we can have this idea of them gathering their knowledge of names of plants and animals on strips of paper. And I might begin this with a brainstorming or a kind of thought shower where they can just note down, and then get them to make it neater, make it nicer. And very cleverly, what you're doing here is you're developing a resource for yourself. So if you have small pieces of card that you can put the names on, you can use them in future years. So that's a really nice thing to do. It is worth, even if you're doing this again, it is worth getting the students to do that brainstorming, to get them to think about how many plants and animals can they name. I read a study recently which talked about how children, really young children, can identify hundreds of brands just by their logos or by parts of their logos, and yet they cannot give the proper names to trees in their local environment. They may know 2 or 3 trees. I mean, and that to me is a tragedy. So one of the purposes of this is to try to get them to make that link between what they've seen on television, what they've seen in real life, and then once you've got this resource, once they've done the gathering, it's something that you can add to over time. So you can have a box in your classroom that's plant names, and they can put new ones in as they find them, and they can also develop them. So when they might start with a local or colloquial name for a tree, or a word like a hippo for an animal, and then progress to knowing what it's actually called. It's a hippopotamus, or progress further to what the meaning of the word is, progress even further to putting an image with that animal, and finding out where it lives and what kind of habitat it lives in. But they can do this if they've got this as a resource. So once you've got the resource established, you can give it out to them as a recurring starter for them to sort, and give them different ways of sorting. So sorting according to classification, like they will touch on in book 5, the animal kingdoms, or the different types of plant kingdom, or at earlier stages, sorting just mammals, or sorting according to habitat, or sorting according to whatever you can think of and whatever you need to cover for the purposes of your lesson. So it's a really fantastic resource that you can create with students and keep referring to. And it can be used, this exercise, not that particular resource, but this exercise can be used for other parts or units or subtopics. So, for example, you could use it with materials, or you could use it with body parts. It will help them to understand this idea of the part and the whole. If you see me looking down a little bit, I've got my notes here, just to make sure that I cover everything that I want to. And hopefully I'm not talking too fast or gabbling too much. Okay, so that's our first idea there. And another one is to begin with some gardening, and a fantastic opportunity to bring in this idea of technology and to get them thinking beyond technology having to be just a mobile phone or computer or a spaceship. Humans have used tools, humans have used technology forever, and we need to think about what those things are doing. And this is obviously really important when we're talking about things like simple machines and trying to get them to think about those basic building blocks. So with this idea, there's opportunity to gather lots of resource, and science, like lots of primary teaching, is that there is pressure on the teacher to gather resource, but they're all things that you can use again. It's also a chance for them to use lots of skills like measuring. I've got camera on there as a reminder to me to a really lovely project that I did with some students, which was that we took photos regularly, most days, of what we were doing, and then we put it together as a little stop motion, as a little video, and it was really nice. And I think it would work really, really well with a garden, to have somebody responsible for going out and taking the picture and for putting them together and to seeing the progress over time, because something like gardening is very, you put in a lot of effort at the beginning, and then there's lots of waiting and maintaining, which feels very light. But then if that works well, there's a good result. And this is something, the garden would not just be useful for your living things, life sciences section. It will come in useful later on when you're looking at other concepts in the other parts of the book. For example, if you grow sunflowers, you can see them tracking the movement of the sun. You can also use leaves and flower heads to cut up and to examine the internal structures. So it's a really fantastic thing, and it creates this idea of this is what we're doing when we're gardening, when we're cooking, when we're going about our lives. We are being scientific. There is a way of understanding these things that will help us to do them better. You can also get them to record what they're doing. So they plan it first, they draw out what they're going to do, they have a certain amount of space, they have tools that they need, and you're teaching then those skills of how to record the process in a scientific way. Okay, just checking, I've covered everything I want to cover again. Oh yes, I did want to say one other thing about this. The difference for bringing environmental issues to life is, if they are caring for a garden, they will encounter problems with it, and then that is an opportunity to make real things like overwatering or too much sun, soil condition, all sorts of things. And another really nice mini gardening activity is to, if they were to do individual plants or even in the class garden, to gather some different pots of soil, different soil types, and within the classroom have as part of one of your lessons an examination of soil types. So for them to sketch the granule sizes, for them to see the consistency, for them to add water or mix different types, adding in sand to different soils, adding in compost. And you can do this on a very small scale, but the actual action of tangibly interacting with the soil is going to be something that they remember the time that their desks got messy, or better still, if you do it outside, the time they've got to make a mess and interact with soil. And then they're going to much more keenly remember the scientific vocabulary that you introduce when you're talking about humus or if you're talking about the different soil types. Okay, so that's another lot of examples for you using gardening. In the books, to return to the books, at the end of each unit, you've got assessment style questions, which, please don't get them to sit down and start with exercise 1A and work through to exercise, 7C or whatever. You'll crush the joy out of them. Use those in parts, okay? So use them at appropriate times. Feel free to chop it up, not literally the textbook, but the order. And one really useful thing is, as a teacher, to go first to the activities, skim read through your unit, go to those activities and begin with them. And then when they return to them at the end, could be some progress. For example, if one of the activities talks about growing something, over the course of the lessons, the weeks that you've been looking at this topic, there may be some progress when they come back to those activities. One really, really lovely idea that a friend did during one of the lockdowns we had here in the UK was that they had to send home a package of work for all the students. The student parents had to come and collect things, and there was lots of online and lots of screen stuff being set up. But this friend of mine included a few seeds for each student, and they grew them at home. And he created a little spreadsheet where he recorded a little table where he recorded the growth of their plants. So they had to report in with their measurements, and they had to share pictures of them, and they had to talk about where they decided to put them, these plants, and how they were progressing. And it was a really wonderful idea. And you don't need a lockdown to do that. You could get your students to do that themselves, and then they're really testing those ideas that they come across in the textbook in their everyday lives. In one of the textbooks, there's a suggestion for a trip. It's really nice to go out into the world and see science and technology in everyday life. So if you have access to a plant nursery, a plant shop, a gardener, somebody who works in parks, a nearby park, any revision site versions, they're good for students to find themselves for revision, for at-home enjoyment. But within the classroom, it's a really good idea to kind of keep it in the real world, so that they keep making that link between science and everyday life. In the books, you've got beautiful, beautiful images, beautiful tables. You've got diagrams, and you can use those. You can blow them up using a visualizer, or you can just start with that photocopied at the top of the page and get students to brainstorm or question around it, or use some of those tools for stimulating curiosity. You can demonstrate experiments. I did toy with the idea of doing an experiment here for you, but that was a bit too much for me to do today. And if they have been growing a garden, use their resources from there. Use the visual prompts that you've presented before. If you have been collecting equipment into the classroom, use that equipment. If you have collected data from somewhere, use that data. Okay, let's go on to the next one. So these are some examples of images from the textbook. And if you have managed to grow something, you can look at your own plant examples. And if you haven't managed to grow something, you can bring in the chickpeas, maize, you can bring in a whole selection of flowers and get them to actually pull them apart. It's much, much easier to actually look at some roots of two different types of plants and get your hands dirty and take photos of them and blow them up and see how they actually look, zoom in, than it is to just read through those pages in the textbook. And then when they come back to the textbook, fresh, after they've done the practical learning, they'll be able to piece together the ideas in the way that you or I can. Without that prior physical experience, they are going to really struggle because they can't just pick up all the detail immediately. Okay, so a really nice thing that I like to do is this idea of for next time, find out. And I've always used this with students. Not all the students will do it, but it's a really nice thing for you to end each session with, to get them to think. And don't make it big, don't make it a massive homework, make it something small and specific, to get them practicing active research and to get them to thinking about science and technology in everyday life. So I have suggested a few ideas already, but some more things that I can think of is things like keeping a record of what food they've eaten, bringing in a menu or a piece of food packaging, bringing in something that they think might be magnetic so that they can test magnets. So for every topic, for every unit in the books, if you do the kind of skim read through and look at the activities and do your planning for your sessions, you can then think, right, where are my hooks that I'm going to put in, and where are my for next time find out things to put in. And this is a brilliant way for you to gather resources. If you say to them, find me a YouTube video that explains X, Y, and Z, you will have a bank to choose from, and you can choose the best one to use in future sessions, in future years. If you ask them to bring in packaging from foods, you can do an activity like the first one that I suggested, where you get them to sort them, and you'll have a classroom full of that resource. Similarly, with any other materials, if you get them to bring in a piece of material when you're doing materials, you'll have a sample board that you can use again and again, and that you can refer to, and that they can interact with. So, definitely I found this works really well, and it's something that I would recommend that you use. Okay, I have not got long left, so I'm just going to bring it together with a final idea of this, making the link between the classroom and the home and science as a subject. So use things that are familiar to them. In the books, there's hundreds of images in each topic of things that are familiar to them. Their homes are full of technology, and their homes are full of opportunities for science and scientific thinking and scientific experimentation. So all these pictures on here are taken from the books, and when you see something that looks domestic, looks like it's from the home, make it real for them. Send them home with those examples. If they're going to think about bacteria, or if they're going to be thinking about heating things and cooling things, or if they're going to be thinking about sound waves and volume, if they're going to be thinking about physical changes, chemical changes, if they're going to be thinking about reversible changes, if they're going to be thinking about healthy nutrition, if they're going to be thinking about magnets, properties of materials, tools, machines, then the opportunities are there. And the images in the book should be a stimulus for you of, how can I make this connection with home? Or how can I make this connection with wider world? And if you get them, like I said in the previous slide, taking a photo, for example, and bringing that in of something at home that has X, Y, or Z, made a permanent change, or a picture of an ice cube, and how long did it take you to make it turn into a puddle, you're making those connections. And similarly, in your classroom, you need to have lots of these things around, and I hopefully have suggested lots of ways for you to do that. So, I could talk loads more about using their kitchens for opportunities, things like get them to use a cheese grater and think about friction, get them to think about magnets in terms of where they're used, get them to cook, get them to use, make Play-Doh, the recipes in the book, get them to take the temperature of themselves and as many things as they possibly can when they've just come out of the fridge and an hour later. Okay, that's a lot of suggestions. So to recap, personal planning is absolutely important in science. We want to get off the page, we want practical activities, we want them doing things, we want them using resources, we want them using tools, and we want them doing research. We want them to have curiosity and wonder. We need to use hooks, we need to use puzzles, we need to use questions. The activities and tasks in the book do this for you, and they're all focused around scientific ideas because we're trying to build this scientific literacy. The textbooks, fantastic, but you use them as a summary, you use them as backup, you use them as revision, you use them to anchor, and you use them for assessment to check that you've covered things, to check that they've done the learning. But please don't bore them. Children are designed to be moving around, doing things, making noise, thinking, learning, and they can't do that if they're sat still for hours on end at a desk. So you need to be brave, and you need to be cultivating this atmosphere in your classrooms. And the more you do it, the easier it will become. I promise you, as somebody who has taken very, very difficult groups of children out to look at museums and write poetry and all sorts of things. I know that you can do these things. So if you're new or if you're not confident, be brave. Make time to reflect. Use the top of the unit SLOs, and that is everything. I hope something's been useful. I do hope if you have any questions and comments that you will raise them. I know we won't be able to cover them all, and Tuba, you're back, so I'll hand over to you.
Thank you so much, Claire. I think that was quite a lot in a nutshell here. That you talked about stimulating curiosity, getting the hooks for the children. And there are so many participants here who actually appreciated the contents of your session here. But we have a few questions. Would you like me to read them out for you?
Yes,
I will also be reading in the comments in between, but most of the participants want to know how to create curiosity in students, how to get them to be curious, because sometimes students just don't, because of lack of interest in the subject, they're not curious, they don't ask questions or they don't respond to questions. So
okay, so yeah. I mean, if I was to have all of you in one room and I was to say, right, who's got a question? A couple of show-offs will put their hand up. I'd say, oh, I've got something to say. But actually, students, if you make them sit still, be quiet, listen, open page 1, have you got a question? Here's my question, answer my question. They're not going to do it. Then, that's not the atmosphere. So when I was talking about hooks and questions and puzzles, it's about, you have to be engaged. If I delivered this talk, I know I'm not the most interesting person, but hopefully, I've put some good pictures, I've asked some questions, I've smiled, I've been welcoming, and your classroom has to be that. You need to cultivate the relationships with the students so that when you ask a question or when you ask them to think of questions, they feel confident to do that, they want to do that. And so some top tips is from day 1, when term starts, create the atmosphere that you want. Create the boundaries, but also, be engaged. So how do you make them curious? You put something interesting in front of them. If I put a textbook and a pencil in front of you, it's okay, it's interesting to read, but if I give you 3 different pots of soil, or a model to interact with, or I take you outside and I get you to build a garden, or I give you measuring tape, colour paper, marker pens, and I say, draw what do you think is inside the human body, or I give you cutouts of the internal organs of a human and say, put them in order, and I make you work with your friend, then you're going to be engaged, you're going to be curious. And if you practice curiosity, you get more curious. So it's a skill like anything else. If we teach children to sit still and listen and shut up, then that's what they will do. If we teach them to move and think and interact, that's what they'll do. So it's our responsibility. It's never the student's fault. Sorry, that's the job.
Absolutely, Claire, I agree with you. And I think that sets the base for inquiry-based learning then, because once you spark curiosity, then the whole cycle or parts of the cycle can then be dealt with within the class or maybe outside the class as well. And you did talk about that, so I think that answers all the questions related to inquiry-based learning. There's a question here about science and technology.
The real world is like. So you might sound impressive if you talk about robotics to somebody whose, life revolves around the most complex machine in their house is a scooter to get to school, but I think, you need to pitch it appropriately, as you know your students best.
Absolutely, Claire. And I think most of the participants agree with you here. They've already mentioned of making use of whatever they can from their, everyday environment. There's another question. They're saying, what interesting topics can be introduced to students for project making?
So you've got hundreds of suggestions through the whole set of books over the years of activities, and they are very much kind of, project based. Throughout the textbooks as well, there's lots of projects. So if you do plan in the way that I recommend, that you as a teacher look through the year, plan your time accordingly, and then put in place what experimentation, what projects am I doing. So something like the gardening project, that would go throughout a whole year. Other projects are much smaller. If you're teaching forces, and you bring in some balloons and some bottles, they're a much smaller project. But all those kinds of projects, there's so many ideas for each unit in the textbook. So I, as a teacher, I'd kind of go through, make a note of all the different projects, and then just choose when to set them up. You might want to front load, do lots and lots of project work, and then as you work through the book, keep going back to what they made and say, oh, now how would you change it? How would you improve it? What would you do differently? Now that you understand this concept that project has been trying to teach.
Thank you so much, Claire. I think you've already mentioned a lot of topics during the session, but what they can do for project making. There's a question here, it's quite a lengthy one, but I'm going to read it out to you. What is the role of science journals for developing inquiry-based learning, as it is believed that experimentation and observation recording is essential as part of the science education that we impart to students? Are there any plans to develop age-appropriate science journals complementing topics in books of science? And that's an idea.
It's a lovely idea, but that's why we have notebooks and pens, because I don't know anyone who's a professional who uses something that you just get as a standard. We're all us adults have different ways of taking notes in different forms, and we want to model styles, but not all students record in the same way. So over the course of their primary curriculum and going into their secondary curriculum, they need to be exposed to different ways of recording and different scientific methods. So sometimes it's appropriate for them to be drawing something, because when we draw something, we look more closely. So for example, if we were to be looking at flower structure, for example, if we take it apart and we draw the parts and we try to break it down to the elements, that's a really useful way for us to record and to retain that information. For something else, if you're talking about, sounds or the environment, traffic passing by, you want them to be outside, you want them to be using some kind of, tally chart or graph. And I think in the textbooks, it's very clear, get them to do this, go and look at this, record this. And where it says record, or where it says write down, or where you think they should be practicing those skills, then their notebook by the end of the year should have a lot of different things in it. And that's another thing. We often as teachers want all their work in their book to look beautiful. So somebody comes in and goes, oh yes, it's all very beautiful. But actually when we're learning, we're messy. My notes in front of me are scribbled on because I'm thinking and I'm adding and I'm developing them. If you want them to produce something really neat, like a report, you model it or you follow the prescribed structure. But if you want them to actually think and record on the job, they need to use different tools. So I would say what they need is a notebook and something to write with, that's how to get them to be scientific.
Yes, absolutely. I think that was something that answers quite a lot of questions about, science journals. And because we usually have them in English language, we used to ask students to write down what they did last night or maybe the previous day. But we don't encourage it in science, and it doesn't need to be kept read. Yeah.
And if you do that activity, for next time, you get them to write it down, and then at the start of the next lesson, you've got that hook. What did you find out? They're starting the lesson. They're speaking.
Exactly. Absolutely.
And they feel empowered when they get to do that because, they feel that they are contributing. They're not just sitting waiting to be filled up. They're developing.
Yeah. I think this is the last question for today, Claire. How do we create a good learning environment, and is there any specific criterion for developing? And I think they mean a learning environment for, for science, maybe, for those students who are not interested.
Yeah, I've been to schools schools where they say, oh, this is our special science room, and the students get to come in this room to do science. And you think, well, then science is special and you only do it once in a while. If we want science to be in everyday life, then our classroom needs to have in it the tools and the technology that we have access to, and students need to use them regularly. So, that's why I use the example of a garden, but also thermometers. We think we'll use thermometers on page 47 or wherever it is, but actually we want to be using them throughout the year, because when you use something repeatedly, when you have access in your environment to those things and you get to use them regularly, you become familiar with them, you become confident with them, and you understand them. So display and visual stimulus within the classroom is really, really important. And lots of the activities that are in the textbooks talk about what to put on the walls, what to get the students to display. That activity that I mentioned right at the beginning of getting their prior knowledge down on pieces of paper and then developing it and creating a display of that, that's how you do it. You make your classroom a bright and colourful thing. And it takes work, but it shouldn't just be you doing it. It shouldn't be the admin assistants doing it. It should be the children doing it, creating it. So, it might not look perfect all the time, but if you have one board that's perfect for your neatness thing, and then the rest of the space, you give students access to the equipment that you're talking about, and B, a stimulating visual environment.
Absolutely, I totally agree. Thank you so much, Claire, for this wonderful session today. I think we discussed a lot of areas, and we can, further talk about them in our own environments. The participants who joined us from different schools today and other institutes also. Thank you once again for joining us today, Claire.
Thank you
And for the participants, thank you for coming in today. I am going to paste the link of the feedback form. We value your feedback. Please do take a minute. It'll just take you a minute to give us your feedback. And for all of those participants who wanted to know how to, manage virtual activities and websites maybe, and something related to English, science, and all other subjects virtually, there is a session on managing virtual classes tomorrow, which will be led by Nida Mulji. Please do join us tomorrow, and it will actually extend on what we talked about today. Thank you so much, Claire. Thank you, participants, for joining us today. And I will insist one more time to please take out a minute and fill in the